Part 2 of Chapter 1, Lesson 7, Inverse Functions, is to take a function, determine if its function is a one-to-one function, and then go ahead and graph both the function and its inverse, taking a look at the graphical representation and then looking at the numerical representation and looking for patterns. Now, to form an inverse when given the equation of a one-to-one function, we are going to switch the x and the y, and then we solve for y. The original function is always denoted with f of x. The inverse function is always denoted with f inverse, or f to the negative 1 power of x. All right, in example 2, we're going to graph the line negative x over 3 plus 2. Negative x divided by 3 plus 2, and I have this line graphed in pink. Okay, this is a line. My y-intercept is a positive 2. The slope is the number that is with x, that is negative 1/3. Okay, so I'm going to go up 2 units and make a point. That's my y-intercept. Count my slope. I go down 1, right 3. And I make multiple points so I have an accurate graph. And then I go up 1 and left 3 is also a slope of negative 1/3. And I connect those points with a dotted line. Now, when we look at our function, our curve, we need to determine first that it is a function. And yes, it is, because the pink curve passes the vertical line test. Then I need to determine if it is a one-to-one function, and yes it is, because it passes the horizontal line test. Now, because it is a one-to-one function, we are going to graph the inverse. But before I can graph the inverse, I'm going to find the equation of the inverse. So I'm going to take the given function, f of x equals negative x divided by 3 plus 2, and I'm going to switch the x and the y, and then I need to solve this for y. I begin by subtracting 2 from both sides so that I have x minus 2 equals negative y divided by 3. Okay, and then to get y by itself, I multiply both sides by negative 3. I will have y remaining on the right side. On the left side, I multiply the entire quantity by negative 3, so I have to distribute negative 3 to the x and negative 3 to the negative 2. To finish, I replace y with proper notation, f inverse of x. So f inverse of x is negative 3x plus 6. This is also a linear equation. Okay, my slope is negative 3, make it a fraction by putting it over 1. My y-intercept is 6. So to graph the inverse, starting at the origin, I plot the y-intercept up 6 units. And count the slope down 3, right 1, down 3, right 1, down 3, right 1, and so forth. Okay, and I connect those points to make a straight line. You know you have graphed everything correctly if you check for the reflection. Okay, the graphs of f and f inverse are always symmetric about the line y equals x. Now, again, to graph the line y equals x, my y-intercept is 0, so I have a point at the origin, and the slope is 1. And so I always sketch in that line of symmetry of y equals x, and just verify if I were to fold the two curves across that line, they will fold onto each other, which means they are symmetric, and I have graphed it correctly. Now, this is what the graphical representation looks like. Let's double check the numeric representation by comparing ordered pairs. So if I list 3 points on the inverse function, okay, the inverse was the line that I graphed in blue. I have a point at 1, 3. I have a point at 2, 0. And I have a point at 3, negative 3. Now, if you recall from the previous page, okay, ordered pairs, okay, on the inverse is found by just switching the x and the y's. So if I take those those three ordered pairs and switch the x and the y's, 1, 3 becomes 3, 1, 2, 0 becomes 0, 2, 3, negative 3 becomes negative 3, 3. This should appear on the other curve. So let me check my pink curve. If I go right 3, up 1, yes, I have a point. 0, 2, yes, I have a point. Negative 3, 3, I have a point. Okay, so remember, we can always compare it with ordered pairs, okay, by switching the x and the y's. We can always compare it on the graph by making sure the two graphs are symmetric about the line y equals x. So to answer letter I, are these points in part G on f of x equals negative x over 3 plus 2? And the answer is yes. Okay, as we switch the x and the y's, there's points on each curve. Now I am going to stop this video. Okay, I would like for you right now, using the textbook as a guide, to answer example 3 and example 4 on your own, okay, with people in the class, so you can form groups of 3 or 4. Just try to keep it within 15 minutes. After you have attempted the graphs in example 3 and example 4, I want you to play video 3 for an explanation.